Ladies and gentlemen, can I just say a very warm welcome to all of you, Your Excellencies, ladies and gentlemen, welcome to BOLDtalks 2013. Now, I'd like to say as a little aside before we start the formalities today, that never in my life have I been involved with a conference or seminar that had such a high quality of presenters as we have today. Literally, they're leaders in their chosen industry fields, and they've literally come from the four corners of the earth to be with us today. So can you join me in giving them all an extremely warm round of applause? Thank you. Now, I'd like to start today with a little anecdote. Let's imagine, let's perhaps all close our eyes and imagine that there are three explorers in a little tent in the frozen wastes of the North Pole. Now, they're all warming their hands in front of a little stove they have in the middle of the tent, and suddenly they hear scratching outside on the fabric of the tent wall. And one of them says, "You know what? That's the sound of a hungry polar bear." And one of the explorers starts to put on his running shoes, and the other two make fun of him. They say, "What's the use of that? You'll never outrun a hungry polar bear." To which he replies, "I don't need to outrun a hungry polar bear. I just need to outrun one of you two." Now, I mention this anecdote because it's perhaps a trivial example of a great discipline called lateral thinking. And I think it's true that all of our presenters today, in some shape or form, represent the state of the art of lateral thinking. And they're using lateral thinking to make quantum changes to the way that society works and thinks. Now, clearly, this is no easy task. How do we make change to areas of particle physics when the mathematics to do that doesn't even exist? How do we make change to the fabric of society when communities and societies don't want us to? How do we help people in desperate need of medicine after roadside accidents when the technology needed to help them is 100 kilometers up the road? How do we find practical solutions to these goals? Today, this will be our quest. Let me focus for a little longer on the topic of lateral thinking. And the best way to do this is to consider the work of the great 16th century Italian philosopher and scientist, Galileo Galilei. He's perhaps the greatest lateral thinker in history, and in the late 1500s wrote four devastating scientific works. They're devastating because wherever possible, he simply didn't need to perform physical experiments. He performed what he called thought experiments. Let's focus on perhaps the best known of these. The story goes that in 1581, in a small Italian town in the north of Italy called Pisa, he conducted an experiment in order to prove the great Greek philosopher Aristotle wrong. Aristotle proposed that objects fall according to their weight, so a heavier object falls faster than a light object. Galileo believed this was wrong. Galileo believed that objects didn't fall according to weight, they fell according to density. And to prove Aristotle wrong, he took two cannonballs. One was 4 times the size of the other one, and they're both made of iron. He dropped them, so the story goes, off the top of the Leaning Tower of Pisa, and to everyone's amazement, they hit the ground at exactly the same time, because their density was the same. Now, the only problem with this story is that it isn't actually true. It never happened. It's a kind of charming urban myth. But what did in fact happen is even better than the myth. Because what Galileo did to prove Aristotle wrong was to think about this logically and to bring lateral thinking to bear. And this is what he said. And this is, I think, an extraordinary example of lateral thinking in intellect, something quite amazing. He said that, say for instance, you take the heavier cannonball and you tie it with a piece of string to the lighter cannonball. If Aristotle is correct and you drop them, then the heavy one will fall first and will make the string go taut to the lighter one, which is falling more slowly. Sounds fair enough. But then Galileo realized that this isn't actually true, because the combined mass of the heavy cannonball, the string, and the light cannonball is actually greater than the mass simply of the heavy cannonball itself. So what would happen is that the string doesn't go taut. Actually, they all fall together anyway. So he provides a devastating logical proof that proves Aristotle categorically wrong. He doesn't need to perform the experiment at all. Now, one of the reasons I mention Galileo is because he's one of 50 or 60 major thinkers in the last 300-400 years who eventually contributed to the realization that we have a set of physical, mathematical, and chemical formulae that could be put together as something called the Standard Model. And the Standard Model, for many years, adequately described, more than adequately described, the way the universe functions and works. But by the 1950s and 1960s, we entered the post-nuclear age. We had new doctrines like quantum mechanics to combine as the opposite of the theory of relativity. And the way that we saw the universe differed markedly from the instructions given by the Standard Model. And in the 1960s, it was observed that the Standard Model actually only accounted for about 4% of what we know to be out there in the universe. And various philosophers and scientists started to think maybe there is a field, and it was called the Higgs field, that actually added mass to particles that accounted for this hidden area of the universe. Now, there were perhaps 10 or 12 leading scientists whose papers progressed this entire area of particle physics. And today, we're fortunate enough to have as our first speaker of the day a gentleman called Dr. John Ellis, who is perhaps the best known of this cluster of leading minds. Now, you may know his work from the incredible announcements from the CERN laboratory in Geneva in 2011 and 2012, saying that perhaps the Higgs boson particle had actually been identified. Now, just by way of introducing Dr. John Ellis, let me say that he's the author of more than 850 leading academic papers, and he's been cited in more than 50,000 academic papers around the world. It's indeed a privilege to have Dr. John here, and I very warmly welcome him to the stage. Thank you very much.